Hi all, welcome back to Cracking the FAANG interviews. If you haven't subscribed already, please click the subscribe button and hit the bell icon to stay updated with our videos. Today I'm going to be focusing on a very important problem and actually a very simple problem. It's called Leetcode 53 maximum subarray sum. And this problem has been very popular at FAANG companies like Microsoft, Google, Amazon, and Netflix. So just by looking at this statement maximum sum subarray, what it tells me is you're given an array and you're asked to find the a subarray within the array which has a maximum sum amongst all the other subarrays. And a subarray is array which with contiguous elements. For example, 1, 2, 3, 4 is a given array. So the subarray with maximum sum is the entire array in this case. So the idea is the numbers have to be adjacent and contiguous. So you can also have negative numbers. So you might not want to add all of them, and you might have a smaller contiguous element subarray. Let's look at an example to understand this better. So the question says you've been essentially given an array called nums, and you have to find the contiguous subarray containing at least one number, which has the largest sum and return its sum. So let's look at a quick example. You've been given array here, and if you add minus, I'll try to break the problem down to make it more obvious. So until here, the subarray with maximum sum is -2. Until here, the subarray with maximum sum is -1. And if you take a snapshot here, the subarray with maximum sum is gonna be -2. Likewise for here, subarray with maximum sum is 4 because 4 is greater, so you just pick 4 by itself. Here subarray with maximum sum is 4 and -1, 3, and so on. So in this example, the maximum contiguous subarray with maximum sum is this 4, -1, 2, and 1 with a sum of 6. You can try this example and pause the video for a bit. And if I give you just one element, you can simply pick that one element and say that this is the subarray with maximum sum. Same here. So I hope the concept is clear. This is a very particular problem, and I call this one of the fundamental problems. What you're essentially doing is you're using an algorithm called Cadence algorithm, which essentially allows you to have a running sum since you are looking for subarrays, and always decide at every point if you want to take contributions from the previous array or you want to start a new subarray from here. When would you want to take contributions from the previous array? If the previous sum plus my current element gives you something greater than my current element, you'd want to pick the previous sum. If my previous sum plus my element gives you something less than or even equal to my current element, you simply discard and you say maybe I can start my array from here. So if there's a negative number from previous sum, so if previous sum is -2 and a of I is 2 as an example, this adds up to 0. Why would you pick 0 over 2, right? You can simply start a subarray from here and the sum is going to be better. So Cadence algorithm is the approach we are going to follow, as I said, and it is a greedy algorithm. The reason I say it's greedy is because at every point you are sort of deciding if you want contributions from the previous sum or you want to start a new sum. So it's not sort of solving exhaustively like dynamic programming or recursion. It's greedily deciding if the new subarray can start from here. All right. Now let's dive into the code. And again, just want to quickly remind you, this algorithm is called Cadence algorithm. So the way we do this is we start with a variable length. We simply pick the length of the given array. And as I said, the base case is if the length is 1, you simply return the first element. If not, what I do here is I create this array. For example, you had the original array given to you is 1, minus 2 and 2. The maximum subarray is 2. So you put those elements, assuming one of the decisions you can make is simply just start a new array from here. So you capture that with this statement. And what you essentially do is you just start with a maximum value. This could also be initialized to float negative infinity. So you essentially initialize the value, and you can also start from the right end. You go from right to left or left to right. Here we go from right to left. And what you do is you calculate the maximum, saying okay, the sum up till here is 2. This is the answer, but from here, does it make sense to do take the contributions of the previous minus 2 plus 2, or which is 0, or minus 2? So it makes sense to take the contributions from previous. It makes the number 0. So I'm gonna replace this decision that I made and update it with the new sum. Same here. So you're at index 0. You can either take the previous contribution, which is 1 plus 0, or you can simply take my current number 1. In this case, it doesn't matter, so the answer will remain 1. And then you can go through the array, pick the maximum, and the maximum is going to be 2 in this case. So this approach that I just showed you is with an extra solution array. So the time complexity is O of n as you're going through each element of the array from right to left. The space complexity is also O of n, but you can actually optimize the space complexity. Since you're making a greedy decision, you don't really need to store all solutions. You can just keep a global and current max. Since you simply care about the previous result and the maximum, so you don't really need a sums array. I encourage you to try it out. In that case, that you'll have two variables, and the time complexity will remain O of n, but the space complexity will become constant O of 1. So I encourage you to try that out. Again, if you haven't subscribed already, please hit the subscribe button and click the bell icon to stay posted with our videos. Thank you for watching Cracking the FAANG interviews. Please like, share, and